you work at the head of a company called AgBiome. What is that company? What do you guys do? And what is your actual role there?
Wow. Yeah, the last one's probably the hardest to answer. So AgBiome started about 8 years ago, and we discover microbes from the microbial communities on our planet that have useful properties. And our core business is identifying bacteria that can protect crops from diseases, insects, nematodes, and the like. So, simply put, what we do is go out into the world. We collect samples of all different kinds, soil, plants, animals, you name it, take them back to the lab, reduce them to just the microbial matter that's within them. So that's basically a couple of filtration steps. We archive those things in ultra cold freezers. So now we have these like undifferentiated pools of all the microbes that were in that sample. And then we can go back to those and identify individual strains of bacteria by, pretty traditional microbiological techniques. And then I think the thing that we started doing early on that was maybe ahead of the curve compared to other people was we sequenced the genomes of every one of those strains that we isolated. So we're now bumping up toward about 100,000 of those, where we have a complete genome sequence, which means we know effectively the entire genetic composition of every one of those strains. And then we can use that as a basis for picking strains that we want to test for useful properties, like can they kill an insect, can they control a plant disease, can they kill a nematode, et cetera. So that's sort of the discovery end of the business where we got going. We now have developed our first product, which is a biological fungicide called Howler. That's been on the market for about 1.5 years. Getting good uptake from growers. It has really good properties. It performs as well as synthetic chemicals do against some critical crop disease combinations. And so we built up a commercial team around that to produce, sell, market that product. And then we have a pretty deep pipeline of additional products coming too. So we're, if I want to steal a term from the IT world, we're a full stack company because we go all the way from a discovered product to actually producing and commercializing it, which is relatively rare in our space in ag biotech. A lot of companies historically have got acquired by somebody when they had a technology somebody wanted, and we made the determination pretty early on we wanted to create a real sustainable presence in the crop protection space that was going to make a big impact on growers' lives and ultimately on consumers' lives as well.
I remember I visited your lab like 3 or 4 years ago, and I was struck by the idea that you guys were doing all this work. You had laboratories, you had offices, you had lots of people working. They were very busy, and yet you had nothing to sell yet. And I remember thinking like how nerve-wracking that must be to be running a business, to be, I don't know if you're racking up debt or you're doing something. Someone is spending money that has not yet been accumulated. What was the experience like of running a startup where you're spending all this money and building all these things before you even have something to sell?
Yeah, that's, I think, a pretty standard phenomenon for people that work in a company that's backed by equity capital. So we have some, very generous and supportive investors that go back to the start of the company. And the assumption is that you're going to spend a significant amount of that equity capital to build value, and eventually the business will be worth enough that they get, a good return on their investment. That's sort of the fundamental idea. We had a big advantage, which was we were able to do some partnerships with major companies relatively early in the trajectory of AgBiome that actually offset most of our negative cash flow. So we were actually cash positive, I think, in year 3 or 4. And those were, our basically R&D partnerships where we perform specific R&D tasks in collaboration with the big partner, who then gets some limited commercial rights in a specific field around that R&D. And that brings money in the door to help build the research platform that we built. It also gives us what's usually referred to as external validation, which means that people that are non-experts can say, hey, well, big company X wanted to work with these guys, so therefore they must have something going on. And it puts the onus on us to keep our technology and our science at the cutting edge so that people do want to work with us. Otherwise, we don't really have very much to offer. So that's been a significant part of our revenue stream, certainly with all of it before we launched Howler, and it'll continue to be a significant part of it for the foreseeable future, because we like doing these partnerships for all the reasons that I said. We've also been able to use that model to get value from our discovery platform outside of our core business. So a good example of this is we created a little entity that worked specifically on discovering novel genome editing tools, generally speaking of the CRISPR related stuff that I'm sure you heard a lot about, because we had like thousands of these things in our microbial collection. So that team worked hard on identifying those, pulling them out, showing that they worked. And then we did a really great deal with a company called Elevate Bio up in Cambridge back at the end of last year, where they got exclusive rights to all that technology for human therapeutics, that's not our background at all, right? We basically have nobody who knows anything about that in the company, but we're now able to capture value in that partnership with Elevate for whatever they do with that genome editing technology, for cell therapy, for gene therapy, you name it. So that, that's one of the ways that we've been able to capitalize on the broad scope of the work that we've done without losing focus on, we're going to stick to our knitting and our core business and crop protection.
So when you're doing crop protection, you've gone out, you've isolated one of these microbes in the soil. You don't actually know which ones do nothing at all, which ones do things that are positive, which ones that do things that are negative. So how does this work when you're trying to figure out which ones? Are you doing like, all right, let's just go ahead and test sample 1 through 100,000 to figure out which one kills the bugs?
Yeah, there's a fair amount of that does go on. That's, what's typically called random screening. You just pick stuff out and test it and see what works. So there's always a measure of that goes on. You can try to bias that in various ways to improve your odds. So one way to bias it is maximize the diversity of the stuff that's going into that random screen. So this is really taking a page out of the book of the way chemicals are screened, the way traditional crop protection chemicals are discovered, the way a lot of synthetic molecules like in pharmaceuticals are discovered. You try to cover as much like space as you can when you're looking for activity. So that's one way you can bias it. Another is you can look at strains that have activity already, whether they came out of your own activities, your own screening, or whether they're maybe products that are on the market or something in a patent. And we can, in a really super quick way, go across our whole genome collection. So let's say we get an initial hit. It looks like it has decent activity on insect X. We can now take that genome and compare it to all the other ones in our database and all the public ones and say, okay, what else is out there that looks like it? And get to a subset that are relatively closely related, and then screen all those guys in the next wave. And that allows you to drive really quickly to like a optimum of a local activity peak, you would call it. So rather than saying, okay, the first found guy is our best one, if you know that there's a whole bunch of other strains related to that first found one, why wouldn't you just test those too? And because the odds are, pretty clearly, 1 over n, whatever n the number you screen are, that first one had the highest activity. So we do a lot of that stuff, and that increases in power as you get more positive data, right? As you get more hits in your screens, and as you increase the size of the genome database that you're working off of. So we're of course getting more positive data on hits all the time, and we have a pretty big campaign underway to kind of massively increase the number of microbial genomes in our collection as well.
So, from an outsider perspective, if you don't know anything at all about crops or about trying to get rid of insects or fungus, you might think like, hey, there must be hundreds of thousands of chemicals. Why aren't we just going and pulling things off the shelf and spraying insects with them and moving on? Like, why are we doing this? What seems like it's not even a needle in a haystack. The needle in a haystack actually literally doesn't capture how small of a thing you're going after. So why do this as opposed to just grabbing things off the shelf?
Yeah, it's, you know, the motivation to do it has gone up over the last couple of decades. If you look at the history of crop protection chemistry, which goes back, you know, roughly speaking, in the modern era is around the end of World War II, through about the year 2000, the incumbents in that industry, which include, you know, my former employer, which used to be called Ciba-Geigy, and a couple mergers later, now it's Syngenta, you know, Bayer, BASF, Corteva, which is the old Dow and DuPont. All those companies did a really good job of identifying new, what we call mode of action chemicals at regular intervals. So those are new ways of killing the thing that you're trying to kill. And the reason you have to do that is because guess what? Evolution says that anything you put out there, you're going to select for resistance to eventually, right? This is just like human pathogens becoming resistant to antibiotics, which is a widespread problem that people talk about. So we've kind of hit the end of the line on traditional crop protection chemical discovery. It doesn't mean there aren't more out there to find. And of course, those companies are still working hard on that. But for a whole bunch of reasons, the discovery rate has fallen off rather dramatically. So in a world where you know you need to keep coming up with new modes of action all the time, where else can you turn? And a natural place to turn is to the microbial world, which is sort of unfathomably vast. You know, the best estimate is there's probably something like 1 trillion individual species of bacteria on Earth. And those things are swapping DNA all the time at a community level. So they're probably evolving faster than you could even collect them. So it's probably literally true that that's an infinite resource of potential activity. And the other thing we know is both from the pharmaceutical industry and to some extent from the crop protection industry, those microbes make a ton of biologically active molecules. And they've been at it going back to, you know, the start of life on Earth, a few billion years plus. So there's been this giant selection experiment that's been going on for stuff that can kill other things for a long time in all the environments where microbes hang out. So why not try to tap that as a source of activity to solve this problem? So that was sort of the two-headed premise behind founding the company. And I'll give primary credit to my best friend and close colleague, Scott Muchness, who's also at AgBiome. He was really the one that promulgated the start of to start a company around this idea back in the summer of 2012.
Thanks for checking out this podcast short. If you'd like to listen to the rest of the interview, it's linked below. And if you like this kind of conversation, you may want to consider joining the Articulate Ventures Network. That's a place where people meet other podcast listeners, get to be a part of a digital neighborhood, and really get a chance to practice things like how they write, their speaking skills, and have a place where they can have an open dialogue with people that want to discuss ideas and leave all of the insults and the craziness of regular social media out of it. So if you're interested, go to network.articulate.ventures.